Hey everybody, we are in chapter 5. We're still looking at multi-step equations and inequalities. And today in section 5.4, we're going to talk about solving inequalities. The first thing we need to do, we don't have any vocabulary words, but we do have some properties. We're going to have two sections of properties. The first, we're going to look at the addition and subtraction properties around inequalities. So I'd like us to take a look over here at this first one. So if A and B, if we have A greater than B, then A plus C is greater than B plus C, and A minus C is greater than B minus C. So let's think about what that means. So I'm going to look at number one and kind of think through an example situation here. So if I had 3 being greater than 2, which we all know is true. This property is saying it doesn't matter what C is. If I add the same number to both sides, this inequality will be preserved. So let's say we're going to use the number 4. So if I start off with 3 and I'm going to add 4 to both sides, notice what happens. So I've got 3 plus 4 over here, and then 2 plus 4 over here. Is the inequality maintained? Yeah, 7 is certainly greater than 6. So addition is preserved. Doesn't matter what type of number you're dealing with, as long as you start off with an equality. If you do the same thing to both sides in terms of addition and subtraction, you are going to maintain that inequality. And the same thing is true if I turned the situation around and I had, let's say, 4 is less than 20. If I add the same value to both sides of this inequality or subtract, let's do subtraction now. So if I subtract, let's say 5 from both sides, right? Subtracting 5 from both sides will yield a -1 here, and it will yield a 15 here. And still you notice that the inequality is preserved. So the take-home point here is that what you do to one side of an inequality in terms of addition and subtraction, you need to do to the other, and the inequality is preserved. So this leads us to our first example. Example 1, we're going to solve an inequality. So here it is. X plus 5 is greater than 12. We're going to check our solution. We're going to solve it and check. So I'll start off with x plus 5 greater than 12. In a lot of ways, we're going to treat this as an equation. So I'm going to do the same thing by drawing a line down the center. But I'm going to keep in mind that this is an inequality. I'm going to subtract 5 from both sides because my law said doesn't matter what I do to both sides in terms of addition and subtraction. As long as I do it to both sides, I've maintained my inequality. So I'm isolating the x like I like to do when I solve. I get 12 minus 5 will give me 7. So my final answer is that x is greater than 7. When I graph this on a number line, let's make that line a little bit straighter. When I graph this on a number line, what I'll see is that, let me put a few numbers here, 5, 6, and 7 and 8. I know that x is being compared to 7, but it's not equal to 7. So I'm going to put an open circle at 7, and then I'm going to shade in the positive, in the greater than direction, because x is greater than 7. So these are the two things you have to do when you're asked to solve an inequality. Let's take a look at example 2. Example 2 is asking us to graph the solution of an inequality. This should be inequality. I apologize. All right. You get it. All right, good. All right, so solve this. Let's start off here. So I'll rewrite this. 3 is less than or equal to b minus 1 2/3. So I need to isolate b. Again, I'm going to treat this like I would an equation where I kind of draw the line and I decide what I need to move around. I want to isolate this b. There we go. I want to isolate this b. I need to get rid of this 1 2/3. So it's being subtracted. I'm going to do the opposite and add 1 2/3 to both sides of my inequality. When I do that, that's not what I need. When I do that, I see that things are pretty simple. Adding 3 and 1 2/3 will lead me to 4 2/3. And on the right side, I'm just left with b, which is cool. So this is my answer. And to graph such a thing, again, let's fix that line. To graph such a thing, that's a little better. I need to make sure and accommodate this number. So 4 2/3, let's put 4 here And since we're doing it in thirds, let's break this into 3 equal parts. And then this will be 5. And so 4 and 2/3, 1/3, 2/3, 3/3, 4 and 2/3 would be here. I'm not going to put an open circle, but a closed circle. The reason for that closed circle is because B is greater than or equal to, B is greater than or equal to 4 and 2/3. So I'm going to put a solid circle here, and then I'm going to shade to the right, because what you want to realize is that all of the possible values of B will be greater than 4 and 2/3. So now we're at multiplication and division properties of inequalities in a sense. And so now I have to be really specific about what's going on. So I really want you guys to pay attention to the examples that I'm going to do for these next two different situations. So when we have multiplication and division, it kind of works like it did with addition and subtraction, where what you do to one side, you do to the other, but there's a slight caveat. So you'll see that in this section here, but let's take a look. In this section, I'm speaking specifically about when C is positive. So if I have A is less than B, then A times C is going to be less than B times C, and A divided by C is going to be less than B divided by C. Let's come up with a quick example. So we know that 3 is less than 6, and let's say the only requirement here for this situation is that C is positive. That's what C greater than 0 means. C has to be positive. So let's let C be, I don't know, 2 or 3 or 2 or whatever. Let's let it be 2. So that's equal to C, right? 2 is equal to C. So watch this. When I do 2 times 3, I get 6. So A times C. And when I do 6 times 2, because that's BC, I'm going to get 12. And notice that the inequality is maintained. And similarly, I can do the same thing over here. 3 over 2 is less than 6 over 2. So we notice that we can do the same thing to both sides of an inequality when we are multiplying or dividing when the C value is positive and there's no change. You'll see the same thing here with this part. This just changes the sign. Says, hey, if A is greater than B, then if you multiply both sides by the same value, AC will be greater than BC, and A divided by C is greater than B divided by C. So let's look at this next part, because this is where, this is the thing that you need to pay attention to. If C is less than 0, what that means is that C is negative. So when C is less than 0, we really have to pay attention. So if I have A being less than B, so a situation like that would be, let's say -2 is less than 4, right? We all agree with that. And let's say C is some negative number. Let it be -1. Let's see what happens here. When I multiply -1 times a -2 to get this AC value, I get a +2. When I multiply 4 times this -1 to get this BC value, I get a -4. And what I want you to see is when you multiply or divide both sides of an inequality by a negative number, your sign flips. It does not stay the same. The orientation of your inequality changes. And you'll see the same thing here. If I did the same thing with our -2 over -1, and then 4, let me put the 4 here, 4 over -1, you'll see the same situation occurs where you can no longer have the less than sign, you need to have the greater than sign, because we've got 2 is greater than -4. So this is something you want to be aware of. And again, I'll restate it. If you multiply or divide each side of an inequality by a negative number, you're going to have to flip the sign. Let's take a look at a couple of examples. All right, so we're going to divide by a positive number. Macy is making each of her 7 friends. I kind of left that out of typing, my bad. Macy is making each of her 7 friends a bracelet. She does not want to spend more than $40 on the bracelet. Find the maximum cost for each bracelet. So when we do a problem like this, we need to consider the situation. So for all 7 bracelets, let B be the cost of 1 bracelet, so that would be 7 times B. For all of these bracelets, she does not want to spend more than $40. So she's cool with 40, so it can equal $40, but she prefer to spend less than or equal to $40. So we're going to figure out the maximum cost for each bracelet. Clearly, we're going to divide both sides by, not 4, not at all. Clearly, we're going to divide both sides by 7. Let's do that. Clearly, we're going to divide both sides by 7 in order to isolate B and figure out what that value is. So I get B is less than or equal to, well, 7 goes into 40 5 times with a remainder of, 5, and then so 7 goes into 50 like 7 times, and then with the remainder of 1, and something like 71 cents. So $5.71 is approximately the value, is the maximum value that she wants to spend for each of those bracelets. And that's pretty much it. Notice that we were dividing by a positive value. The sign doesn't change. Let's take a look at these last 2 examples. So here we're going to solve the inequality in graph. I've got -5 times x is less than 45. If I divide both sides by a -5, this should be like a red warning for me. This negative, as soon as I'm doing something to both sides of an inequality with a negative, I immediately circle my sign to help myself remember that I've got to flip it. And then so now x is greater than 45 divided by -5, and that's going to be, it's greater than -9. Similarly, here we have the same thing. Take a look. We're going to solve for b. To get b by itself, we're going to have to multiply both sides of this equation by a -8. Because of that move, because I'm going to do that, I'm going to multiply this side by -8. I'm going to get rid of this. This is just the b for like problem A and problem B, but it's kind of in the way. So I'm going to multiply both sides by -8, or try to. Let's see if my computer will let me do that. Doesn't seem to like it. I'm going to rewrite this problem. Let's try this again. So we have b over -8 is greater than or equal to -6. Multiply both sides by -8. And as soon as I do that, the warning bells in my mind go off, because when I do the same thing to both sides of an inequality, when I'm dealing with a negative number, the sign flips. So I circle it, I flip the sign. And now I know -8 over -8, or -8b over -8 is going to be 1b. So I cancel out my -8s and I'm left with b. -6 times a -8 is going to give me a positive 48. So we didn't do all of this problem. The second part says to solve each inequality and then graph the solution. And we're comfortable with graphing at this point. You need to find yourself here. So here is our -10, -9, -8. Give ourselves a few points. Open circle at -9. And then we're going to shade, since x is greater than, we're going to shade to the right where the values are greater than. And then over here, as we're looking at b, we recognize that, let's do 46, 47, and 48. B is less than or equal to 48. So I'm going to have a solid closed circle there. And then I'm going to shade everything to the left because b is less than. All right, guys, I know that this wasn't the easiest or quickest lesson, but if you have any questions, please let me know. I look forward to talking to you tomorrow. Have an excellent day.